talk about making VuFind fault tolerant and load balanced. This is something we have been doing since the beginning of our project, and here is some background on the project and the requirements or the reasons for doing this. I'm sort of the guy who dives to the deep end, to the horror of server administrators and other people. So even if it hasn't been done before, we're just going to do it in production and see if it works out. That's well, when you're limited with resources, that's the way to easily get enough mass to test things out. But it's been good. So our project Finna is part of the National Digital Library Initiative in Finland, and it consists of some long-term preservation and then the discovery side. And as I mentioned, it's an interface for all Finnish archives, libraries, and museums. We sort of thought about starting with just a few libraries, but it's easier to get funding when it's huge. So we're doing it big. We also started with a commercial product, but it was soon determined that there's no such thing that works for all the requirements that we have, all the diverse metadata and hundreds of data sources and so on. So the development of the VuFind-based service started in 2012. And at that point, VuFind 2 was still something to become a viable alternative, so we had to start with VuFind 1. And it's in retrospect, it's sort of good because we hacked the VuFind 1 version and did stuff in a really quick and dirty way, and now we can clean it up. But it's a lot of work. One of the reasons for rethinking this architecture and how we run the service is because almost all of our older services have some planned downtime. Usually it's daily and it's annoying. For instance, Voyager, we have to shut down during the evening to get the complete backups, and same with Metalib and all the other systems that they need some cleanup runs or something that has to be scheduled to run daily. So we wanted to avoid any of that. And we also wanted to avoid downtime caused by scheduled maintenance of the underlying operating system. So we want to keep the servers up to date, but we don't want the users to see that we are doing any service. And of course, to try to make things more reliable if something fails. Here's the only picture in my presentation. So as you can see, Solar is in quite a central role, and well, it's the most important part from the, of course, apart from the user interface, but it's the big thing that needs to run all the time. And then there are other services like a record manager that we use to index the data, harvest it from other places, that it's not so critical, so we can run that in the background, and it's not time critical. It doesn't show up to the end users if it's not running or if it's not working. We've also had to make statistics sort of not that critical, because there are some issues with running PVIC in a load balanced architecture. Okay, just a little bit of what I mean when I talk about fault tolerance and load balancing. In this case, fault tolerance is that means that if we lose, say, one front-end server, the users won't notice. At least not that much. We have a hardware load balancer on front of the system, and it's always taking a few moments before it realizes that something is down. So a user of you may lose some requests, but it's mostly seamless. I would like it to be better so that we could configure the load balancer to try again with another server if something's not responding. but it seems that it's at least that device is not capable of doing such sophisticated stuff. And of course, it's not possible to do that with all the requests. I mean, it would be easy to try again a request for some static assets like images or CSS files, but if you try again a post request that changes something, it may not be something that you want to do multiple times. Load balancing for us means that we can use a couple of smaller servers instead of one huge one. And it also makes it easier to scale up by adding servers instead of adding more hardware to a single server. In practice, it means that we still add hardware to the servers we have because it's easy, and adding more servers is more difficult. But there will be a point where it's cheaper and more manageable to just add a new server. Here, each of these servers that are run behind the load balancer include all the critical services for VuFind. One of the typical things that services running behind load balancers do is that they require sticky sessions. This means that the initial requests from a user's browser goes to one of the front-end servers and will stay there. So the load balancer sets a cookie or uses some other mechanism to always map the user to the same front-end server. But this means that if that server goes down, you will lose the session. And that's also something we wanted to avoid in this situation. Otherwise, it's not transparent to the users. So the components we run load balanced are here. Of course, VuFind as the user interface itself. Then the underlying database, we use MariaDB instead of MySQL, but that's quite trivial change. But we use the Galera cluster so that we have this multi-master database so that each of the front-end servers have their own node, and it will replicate synchronously, mostly synchronously, but anyway, seamlessly, so that VuFind doesn't need to care about that. Then we run Solar 5, currently Solar 5.3 with Solar Cloud. So it's again currently 3 servers running the cloud, and each having a full replica of the index. We also use Shibboleth, so we need the service provider to run on all these servers. And we maintain all the configuration and package installation, system upgrades and everything using Red Hat Satellite. There are of course many tools to use this, to do this, but Satellite is used by the guys who manage the server hardware and the operating system, so it was quite easy choice for us. It's sort of cumbersome in some ways, but it's still good to have a place where you can store the configuration files, for instance, and deploy them to all the servers instead of having to manually modify or copy the files from server to server. As I mentioned, there is a hardware load balancer. In our case, it's Cisco Ace. I don't really know about the details because the hardware guys manage that for us. I suppose it's good, but who knows? At least it took our recent hardware firmware upgrade for it to support the SHA-2 algorithm. So we were almost in a trouble since Chrome users started to get issues with the certificates. Of course, there are also software-based solutions. HA proxy is quite a prominent one, a lot used. But then there is always the problem that if you use one of those, there is one more server that you need to manage, and there is again a single point of failure. we actually have two load balancers. So one is on standby if the primary one fails, and it has happened once. And it was a mysterious failure. It just started to fail some of the requests and started to report that servers were spuriously going down and up and failing and being suspicious and everything. And took a while to determine that there is nothing wrong with the servers. It was the load balancer acting up. I'm not sure if it was ever determined what the primary cause was, but switching the balancers and upgrading some firmware or something helped. We currently run everything in a VMware cluster. All the servers are there, including the front-end servers. We try to keep the load on all the front-end servers as symmetric as possible, so that the sort of random load balancing that happens by the balancer works out well. So each request has equal chance of going to any of the front-end servers, and if you have the same services and load on each of them, they will stay sort of equal, more or less. Then we have the one backend server for harvesting and indexing as I mentioned, and in addition to that, we have some staging servers and development servers, and Pivik runs on its own server. So this means that we have a monthly downtime of about 2 minutes or so, but we can live with that for the Pivik service. So the load balancer is set up to distribute the requests randomly. There could be, of course, something more advanced to check, for instance, the server loads and distribute more to the ones that don't have so highest load. But this is an easy way to do it, and doesn't need to do so much work when determining where to send the requests. There is now a nice service in VuFind that you can be used to check whether the service is healthy, and we use that to, well, actually we are using VuFind 1 at the moment in production, but with VuFind 2 we will use the service to check the server health, and that way the load balancer knows which servers are available, so it doesn't send the requests to those that are not. Since the load balancer is using TCP/IP to forward the requests to the front-end servers, we need to map the incoming IP address of the requester on the front-end servers, so that we don't need to support any fancy ways to determine the actual IP address. Otherwise, all the requests would come from the IP address of the load balancer, and for instance, determining which users have access to the Primo Central index that we use would be impossible. We use an Apache module for mapping the header that the load balancer sets the X4 for to the actual remote address, so we don't need to change the software. And the services DNS entry points directly to the load balancer. There are, of course, ways to sort of load balance services by using like random or multiple DNS addresses that are randomly served and things like that, but that's, in my opinion, not real load balancing, or actually it's load balancing, but it's not fault tolerant. And okay, so VuFind and Apache have identical installations on all front-end servers, and mod RPA is the one that maps the IP addresses. We also have additional logic in VuFind that's also now in the VuFind 2 core that allows one to define multiple Solar addresses, so that if the Solar server on the local front-end server is down, it will try another one. And that's useful for being able to update Solar in a running production environment without any downtime. So you can restart a Solar index on on one of the front-end servers. And if, of course, if it happens to run out of memory or something, it doesn't ruin everything. Scheduled tasks are run on one of the front-end servers, so this is one of the asymmetric things, but it's not significant in adding to the server load. Alpha browse indexing needs to run on all servers. We don't actually use it at the moment, but if it's used, it needs to be handled on all the servers. Or you could also, I suppose, run it on one and distribute the index files to other servers. But there is no mechanism to automatically replicate them. Then there is the database for sessions and everything. We have one node on each of the front-end servers, and they provide a cluster, and it has been working really well. We also use the Percona extra backup to back up the database, which means that we can do a backup online, and it doesn't block the database access, the write access to the database, like some other solutions do, and provide still like consistent backups. It needs several TCP ports, which are listed here just because they are not always listed in all the documentation. So if someone sets them up, it's good to know. Solar Cloud, as I mentioned, every front-end server has one instance, and it's full replica of all the index. So we are not using shards yet, but that's also one option that we have, that we can sort of split each front-end server to two parts and split the index in them. So that's probably something to be done in the future. We use external zookeepers to handle the Solar instances, and they are also running on the same front-end servers. Solar Cloud distributed all the updates to the index automatically to all the front ends, so there's nothing special that needs to be done in that regard. As long as you use HTTP to do the updates. If you write directly to the index, you're on your own. Here are again the TCP ports, if someone needs to set up firewalls. Shibboleth was slightly complicated to set up, since it's usually using some sort of shared memory or a memory cache to store the session details. And we needed to make it so that if a user initiates a Shibboleth login on one of the front ends, and after login returns to another one, they are still aware of the session details. So we switched to the ODBC storage, so the data is stored in the MariaDB cluster. It's also quite handy to have everything there, so we don't have to worry about replicating the data. And of course, yeah, this also helps in making sure that no sticky sessions are required. One thing we noticed that if you run VuFind-1 with Shibboleth, the default configuration makes everything go through the Shibboleth module or the Shibboleth authenticated directory, so the virtual host, which means that when the load increases, the Shibboleth module that Apache uses becomes a bottleneck. So we changed the configuration just a little bit so that it's only for index.php. That helped a lot. And Red Hat Satellite for configurations, packages. It can also be used to run commands, but it's really cumbersome because you need to go check the logs for results and everything. So I don't really like to do that. At least with the 3 front-end servers, it's much easier to just fire up 3 SSH sessions and run the commands and see that everything works well. it is a bit clumsy. I haven't really used Puppet or other tools, so I can't compare those. But if you have a choice, you may want to consider other alternatives. Besides, I think Red Hat Satellite is not free. So what are the benefits of all this? Fault tolerance, yes, it works in practice also. So we usually install operating system updates once a month, unless there are some really critical ones that need to be installed right away. And we do it so that they are done one front-end server at a time. And we have been able to keep the service running all the time. Apart from maybe one instance when they did it too fast, so the Solar cluster didn't have time to come up. Load balancing, it's working great. There are some minor differences in the actual underlying hardware on the nodes. So there are minor differences in the typical loads that the servers have, but the requests are handled in a timely manner, so there are no problems in that. And as I mentioned, rolling upgrades for Solar have been really useful, since we are running quite cutting-edge versions of Solar, and there are sometimes issues with those. But there are also reasons why we do that. Downsides. For instance, cache directories are local to each server. So currently, as we used some archival data and we have EAD records with hierarchies, the trees must be built on each server. So we are not doing any kind of pre-building of the hierarchies. They are done when the first user requests them. And we could maybe distribute them rsync maybe, or have a shared disk or something, or maybe cache them in the database or something to make it work better. And Alpha Browse, as I mentioned, must be available on all the servers. And it's a heavy process in a large index. Solar's more like this query handler doesn't work in sharded indexes, so we can get away with that when we have full replicas on each of the front end. But if we start sharding the index, we need to change to the new, more like this handler that's supposed to be now feature complete and be able to do the equivalent as the old query handler in Solar 5.3. But I haven't tested it yet enough to see if it really works. Regarding PVIC, it can be run in the cluster, but there are some issues. So it's much easier to run it on a single server and let it be that way. It could be possible to queue the PVIC calls done by the clients, so that we wouldn't lose any of those, and we could sort of load balance that part of it, so that PVIC could just process the queue in the background. But that's something that we need to see maybe in the future. Then there are some pitfalls, and these are nice. Since browsers, since it's really good to cache CSS files and image files and everything in the browser, we need to make sure that they have the same timestamps on all the servers. We deploy changes from Git, and it's of course impossible to make sure that all of them have the same timestamps if you do a Git pull on 3 servers. So now we actually use the commit time, last time of commit, and set the timestamps on all the servers to that. Seems to be working. And the file modification time is not the only mechanism used by browser and Apache to check that the file hasn't changed. There is the e tag that's calculated by default from file nodes creation time, I think. And there's no really good way to set that or modify that. So you need to change the Apache configuration so that it's using the file modification time and size to calculate the tag. Something I didn't notice until recently is that the Solar Cloud distributes the queries itself randomly to the nodes, unless you set prefer local shards to true. And of course, it doesn't hurt that much, but it's not really beneficial if you are already randomly distributing the user's requests to one of the servers that the Solar Cloud is again distributing the queries. It's always adding a little bit of overhead by going through HTTP to another server. So we use that as a default parameter in Solar config. MariaDB cluster needs to be manually bootstrapped if it goes down. This is, I suppose, to make sure that it doesn't do anything stupid, since it can be quite critical to keep the database consistent. And in a situation where the database can't be sure that it's running the latest version of the database, it can't recover automatically. I think we've only had one occasion where we needed to do that. I don't remember how we ended there, but it's a rare occasion if you make sure that you only shut down one server at a time. So as long as there is one server running, you're all good. Something we learned was that the Unix ODBC drivers that Shibboleth uses crash regularly on Red Hat Linux 6 that we are still running. So we had to roll up new ones to make sure that their Shibboleth daemon keeps running. And there is, of course, always something that can be done to make things better, like sharding the index, which we need to do sometime in the near future. I just checked that our current production index has 140 data sources, which means that it's going to contain 22.6 million records, and the index now takes 52 gigabytes of disk space. We can still easily run this on a couple of front-end servers with 64 gigabytes of memory. But the test index that we use, where we index the databases first before they go to production, already has 274 data sources with 44.7 million records. And it means that it's already 117 gigabytes in size. And that's getting a bit on the large side. If you shard the index, we want to keep it manual so that we can have each front end so that it can be restarted with all the shards of that front end, and not that we get a mess of shards on all the front ends and don't know what to restart anymore without causing any trouble. And it of course also helps with the maintenance of the servers if you know that you can restart these two together and it's not going to cause trouble. You don't have to go through them one at a time. Maybe to ease the performance problems that I anticipate at some point, the test index is also already being a little slow, even though the server has more memory, is that we could see how it goes with SSD disks or more memory, or mess with the garbage collection settings, which I don't really like to do, but good, of course. And then what about load balancers? Do something nicer with them. So there are a lot of different options that we are going to need to do in the future. There are some other things that I've been also thinking about like leaving full records out of Solar, which would affect the index size quite a lot. But then it means that we probably need to make sure that record manager's database is fault tolerant too. So it creates another point of possible failure. And also with the unnamed commercial product we tried to use before going with VuFind, we had the problem that it first harvested the records to our Oracle database and then updated the indexes. And for instance, when records were deleted, they were kind of sort of disappearing from the Oracle database before they disappeared from the index. And this meant that the user could find something that wasn't anymore kind of available. So we would need to make sure that everything like that works. And of course, we currently have some fairly heavy operations like deduplication running in Record Manager, and it may slow down access to the database that it uses. It's using the MongoDB or actually TokuMX in our case. So we wouldn't want to make it kind of performance critical part of the installation. Here are a couple of links again to the documentation on setting up Solar Cloud and everything. We have our own Solar package that we started to build at some point to be able to upgrade it independent of VuFind. This of course means that we are in favor of decoupling Solar from VuFind, but we also understand that it's important for users to be able to install it easily together with VuFind. So maybe it's a packaging thing. I also, then there is the MariaDB cluster page. I think that's the best page to start with, and there are of course other pages, but the documentation is sort of scattered, and it's not always easy to get started with those. I put together some information about making VuFind fault tolerant in the VuFind wiki, so that the information wouldn't get lost. I guess maybe I cannot make it open, or I can. So here are the very basic parts of how we've done it, and some of the actual setup things you may need. So if you're interested, go here first, and then you can ask me when I haven't put up everything that you actually need to do it. Not bad, maybe. I don't know. It's interesting that when we started doing this, I asked the guys who run the servers and who had quite a lot of experience with MySQL and everything, how about if we do this clustering thing, and they were like, we're not doing that in any of the bigger services either, so we don't really recommend you to do that either. But we did it anyway. So it's sometimes a little bit scary, but it has been working out really well. So I guess in this case, the use of the database, for instance, is not so heavy that we don't constantly run to, for instance, deadlocks with the database upgrades or database updates and things like that. So that helps too. But there have been some bumps on the road with Solar Cloud and well, especially Solar Cloud. Sometimes there have been versions that fail to recover from a down node. So it's been interesting. If you have any questions, I'm really happy to answer those. And of course, it's okay to also send me an email if anything arises, if you want to do something like that. Yes.
So how are you dealing with sessions at this point? Are you able to be completely non-sticky, or are you still using?
Yeah. So in VuFind we use a database for sessions, and that's already a built-in function and a built-in functionality and works really well. And that's the most important thing. And then we use Shibboleth with the database storage, and that's also enabling us to keep that also non-sticky. Other than that, there are no needs to make anything sticky. So those are the main components, and it's working out well. I've seen that Shibboleth is sometimes causing deadlocks with updates of the session data. I haven't been able to track down when that happens, if there is a reason for that. But there hasn't been any complaints about it not working. So I suppose everything is good in that regard too.
So how does the cluster recover from deadlocks? Does it just have a timeout and rollback, or?
It's kind of opportunities updating the database. So if there's a deadlock, one of the transactions will fail, and the other one will prevail. So it's the first one that gets through that will prevail, and other nodes will fall back to that. And it depends on the client software if it handles the failures properly or not. So I'm not quite sure what the Shibboleth daemon does, because I haven't dug into the code. But supposedly it will retry the transaction after checking the database status again. And things should go well with that, or do something more sensible if it doesn't need to update it or anything like that. But also the Shibboleth session storage is quite simple, so it's only storing a couple of fields of data for the user, so it's not really critical. I believe that it could be a collision of timestamps for the session, or for the session cleanup or functionality, so it's probably not critical. But it's the world where we live in. It seems to work well, and we are happy with that.
This is wandering a little afield, but I saw there was something on the mailing list about performance problems with faceting in Solar 5.3. Have you run into that?
Yeah, we have. But there have been a lot of different problems with Solar 5. There have been highlighting performance issues too that have been worked out for the most part. We do have doc values enabled for some of the fields, but since the text facet fields don't support doc values, we can't enable them. Nevertheless, it seems that the performance at the moment is acceptable. So when I last checked, for instance, highlighting is taking much more time than faceting. Like if the query takes half a second, highlighting maybe 200 milliseconds on that, and faceting is 50. So I don't know in which situations that those problems arise. Maybe if the server is limited on memory, right. It could be a major cause of problems. But since, as I mentioned, we have doc values enabled for those fields that support it, it may be that it helps. That reminds me of the fact that I need to check at some point if we could get rid of the text facet field type. I haven't really checked, because we are running sort of a modified VuFind schema, but it's the basic fields are the same. So, and I've tried to keep it compatible. So it's still using the text facet field type, and I'm not really sure why.
My vague recollection is that field type may at least be partially motivated by a desire to strip trailing periods off of things.
Yeah, that's possible.
Which is a fairly trivial reason to define a new field.
Yeah. I would do that in the indexer, right, rather than in the schema. So I guess that might be reason enough that we will change the schema at some point so that we can enable doc values for those fields too. at least I can say that reloading the index is quite a bit faster with doc values enabled, especially with a large index like we have. It was like 5 minutes of warm-up for simple queries that were creating the uninverted indexes without doc values, and now it's like under a minute. So it makes a difference in real life too. If there are not any more questions, thank you.
Thank you.